Hi everyone. So for those of you who arrived late, my name is Andras Danis. Welcome to CU. My topic today is how to use ChatGPT and other large language models in a finance job. Of course, everyone here in the room has heard about ChatGPT. However, every time I talk to people, many times I get this feedback. I'm sure this is, to those who are not power users, I get often the feedback, this is a great tool for producing funny pictures and cute songs and a poem in the style of William Shakespeare, but how is it useful in my daily job, right? So a lot of people are skeptical of this tool because they only want to use tools that can make them more productive or more efficient in their job, or to get, in other words, to get more work done in the same amount of time. So this is what this talk is about, how you can use it for certain tasks to make you faster, and at the same time, what are the tasks that are not that appropriate for ChatGPT and other large language models. So I want to start with telling you about some recent developments in the world of large language models. Some of you might know this already, but I hope that everyone can get at least some useful out of this. Second, I want to tell you about tasks which are surprisingly not that appropriate for large language models, even though you would think that a computer can handle that. And finally, I want to talk about tasks which, at which these models are extremely good at. So let's talk about some recent developments. But first of all, I want to mention also some resources that I use day to day, and maybe you will find them useful as well. There are two great blogs that I can really recommend. One is by Simon Willison, who's a software developer in the US, and it's an extremely frequent blog. He updates it almost every day. Another blog that I can highly recommend is by Ethan Mollick, who is a professor at Wharton Business School, also in the US, and it's also an extremely up-to-date blog. And I used many of their tips also myself. And finally, Ethan Mollick, the same guy with the second blog, also wrote a recent book. It just came out last year about, it's called Co-Intelligence, about how humans can use AI tools in their work. Now, let's talk about some recent developments. One website that I want to share with you that I find really cool, and maybe you will find it exciting as well, is this website here. It's called the Chatbot Arena LLM Leaderboard, which is basically a ranking, a very up-to-date ranking of all the existing large language models out there, not just ChatGPT, but all of them. And if you look at that ranking, I downloaded this a few weeks ago, so maybe by today it has changed a bit. But you have, right now on the first spot, you have Gemini 2.5 Pro by Google. On the second place, you have Llama 4 Maverick, which is a model developed by Meta or Facebook. On place 3, you have ChatGPT 4o. Which is, of course, by OpenAI. Then you have Grok, developed by xAI. Further down, you have DeepSeek, famously from China, which has raised a lot of news lately. So first of all, it's I think, very cool to see how they compete with each other and how well they're performing. But the other really interesting takeaway from this table is that there has been an incredible amount of entry into this market. Many, many companies have entered this market and are fiercely competing with each other, which also explains why the speed of development is so extremely fast in this industry. I've also written down the names of some of the companies that compete in this market. So it used to be 2 years ago basically just OpenAI with ChatGPT, but now there is more than a dozen companies with very serious, highly competitive models in this industry. All right, so check out that website. I think it's very interesting. Another recent development is that the most recent models are so good that they can beat a human PhD in their own field. Okay, so what does that mean? What this standardized test does is the following. It asks people with PhDs a series of questions. Some of these questions are in their own field, physics, chemistry, economics, whatever, and some questions are in different fields. And the human subjects are allowed to use Google search also when answering questions, okay? So the bar is actually pretty high, right? These are very well-trained people, and they have Google at their disposal. People who are answering questions in their own field can answer about 80–85% of the questions correctly. If you get a question outside of their field, the average person can answer about 30–35% of the questions correctly. So that's the lower blue bar and the upper blue bar. 2 years ago, or just less than 2 years ago, already the most advanced models were able to beat PhDs outside of their field. But now, just 1 year later, they can beat human PhDs within their own field, right? This is the upper line here, which is quite remarkable. Another recent tool that I want to share with you, and 1 year ago this did not exist and people thought this is impossible. OpenAI has a new mode, which is called the deep research mode, which can produce, which can help you with your research tasks. This can be industry research, this can be academic research. Of course, it cannot do all research alone, but it can help you a lot with research. So let me give you one example. And by the way, the reason why this is fascinating to me in particular is in the past, large language models were pretty good at pretending to produce original research, but there were a lot of hallucinations in there, especially when it comes to academic citations or industry citations. Many of those citations were just made up, okay? And this is a serious problem, of course. This problem has been reduced dramatically. So let me show you an example of a prompt that you could add. This prompt is from Ethan Mollick. It goes like this: when should startups stop exploring and begin to scale? I want you to examine the academic research on this topic, focusing on high-quality papers and RCTs, randomized control trials, including dealing with problematic definitions and conflicts between common wisdom and the research. Present the results for a graduate-level discussion of this issue. Okay, so a very nuanced question with a lot of pros and cons. And what the tool does is it doesn't immediately jump to an answer. Instead, it interacts with you and asks you follow-up questions. Okay, so it's curious, and it asks you a series of follow-up questions to be really sure to understand what you want to know. And then you hit enter, and then the reasoning process starts. So there's a whole sequence of reasoning steps which you can observe on your screen in real time, and you can see a little bit behind the black box or inside the black box and see how the reasoning process works. This takes a few minutes, actually, not just a few seconds. And at the end of it, you get the output, which in this case is a 13-page PDF report with about 3,700 words. There are several academic and industry citations embedded in it, and none of them are hallucinations. These are real citations. If you click on them, it will take you to the actual journal, to the actual article. And the quality of the writing is also quite good. So this is remarkable, right? A year ago, this was not possible yet. Let me skip over this. All right, other recent developments. Most models by now are multimodal. What that means is they can not just take in your text, but they can take in pretty much anything. They can take in an Excel file, a PDF file, they can take in audio, they can take in video. A lot of things can be taken in. The audio sometimes can be interactive or in real time. The video feed can be in real time, which is quite remarkable. Also, some models can write computer code with audio input only. So I was listening to an interview with this Simon Willison blog writer, and he said he went for a 1-hour walk with his dog. He had earphones in, and he was talking to a large language model and verbally explaining in plain English what kind of computer program he wants it to write. By the end of the walk with the dog, the computer program was finished and it was running on his computer, which is quite remarkable, right? And finally, the last bullet point is about not just writing code, but executing code. So the most recent models can not just write computer code for you, but they can execute it for you. Then you can look at the output, and you can feed in the output back into the model, and it can iterate until the program is so polished that it does exactly what you want it to do. This doesn't work with every language, but for Python code, for example, it works well. Okay. Now let's come to tasks where you would think that large language models are very good at naturally, but they're not that good. Okay, for example, searching for factual information, stuff that you would in the old days look up on Google or on Wikipedia. Very often it gives you good feedback, good information, but sometimes it's just complete garbage, and it's very hard to tell when is it good information and when it is a hallucination. Another example is simple calculations. You would think that a computer is very good at computing things, but somehow large language models are different from standard computers, and somehow they're not that good at always computing things. Sometimes they're good, sometimes they're not. So overall, my advice would be to be very skeptical and careful when you use these tools, when you cannot evaluate the output very well because you're not an expert in that area. Be very careful, because sometimes they just mess up and sometimes they hallucinate. Okay, let me give you one example. So in the finance domain, calculating the NPV of an investment project, right? Calculating the net present value of an investment project. We do this day in and day out in finance. You would think that LLMs are good at doing that? It turns out no. They make a lot of mistakes. They produce a text output which at first sight looks extremely good, but if you dig into the details, there are several mistakes in the calculations. Okay, now let's move on to some tasks where LLMs are really, really good at. One example is this. I use this quite often in my own work, extracting data from a PDF file. You might have run into this problem as well yourself. You have a PDF file with some data embedded in it, maybe in a table format, or maybe spread throughout the document in text, and you want to extract the numbers. And in the old days, you would hire an intern who would type in the numbers for you in an Excel spreadsheet, right? So this could be easily done with an LLM these days. You give it the entire PDF file, it extracts the data for you, puts it in a spreadsheet, maybe even visualizes the data as a graph for you. So this is something it's very good at. Another example is this. Let me give you this prompt. Create a dashboard for this income statement and make it good. What it means is make it look good on a big screen of a desktop, make it a website that also looks good on a small screen of a smartphone. This is what it means. So what you do here is you basically upload an income statement or a balance sheet in an Excel file to the LLM, and you want to have a visual dashboard that summarizes with a cute graph the most important information in the income statement. And this is the output, okay? So it's with just one sentence in plain English, you get this nice dashboard. But this is not everything. You want to make this fancier, so you add a follow-up prompt, okay? This could be the follow-up prompt. You say, can you add the ability to do a sensitivity analysis? So you want to change some input parameters and see how the graphs change in real time on this website. So it produces this interactive website for you, where you have these drawers, and you can change some of the input parameters and see how the graphs change on the dashboard. And then you can take it a step further. You can say, okay, this is nice, but I want it to be a little bit more sophisticated. Please add a Monte Carlo simulation using a normal distribution, okay? And it can do it. Just one sentence, and it adds a Monte Carlo simulation. You choose the parameters of the distribution, and it draws a lot of draws from this random distribution and produces the output for you. The output could be future profits or future firm value, etc. Some other tasks that LLMs are extremely good at. This is a task that I use it for the most personally, which is writing computer code. This is I think, very interesting because more and more of our students get into the world of coding, but they're not super confident because they say, well, I'm a beginner coder, I'm an intermediate coder, but I'm not a professional coder. This tool actually allows you to go from a beginner coder to become an intermediate coder, or if you're already an intermediate, it can make you a very good expert coder. How does that work? One way I use it is, for example, to upload the entire code script if I have a bug in it, and it finds the bug for me. It finds the mistake for me. Another example would be I describe a task in plain English, and it gives me the line of code which does exactly what I want. This could work one line of code at a time, or you provide multiple sentences in plain English describing all the steps that you want it to do, and it produces the entire code script for you. There are two ways to use this tool. I use both ways. For example, you can use it in a browser in ChatGPT, or you can use it directly in the code editor that you work with. So if your code editor is VS Code, or if your code editor is RStudio, whatever code editor you use, you can use the Copilot tool, which is in the background uses ChatGPT as well. Let me give you a screenshot of how this would look like in an actual setting. So this would be my code editor of choice. This is RStudio. On the left-hand side, you see the code that I wrote. On the right-hand side, you see the console. And you see in green, a short sentence that I wrote in plain English, right? Download the stock price of NVIDIA for the past 4 weeks. Just plain English. And in the next row, in gray color, it already writes down the R code for you, which does exactly what you want, and it figured out all the details on its own. I didn't tell it to use the data from the Yahoo Finance server. It just assumed that I want that, and it turns out it's exactly what I wanted. Okay, so to wrap up, it's not easy to find out which tasks large language models are good at and which tasks they're bad at. You have to experiment a lot, sadly. This is a downside of LLMs. We have to all get used to these tools and experiment a lot. What I recommend and what I do myself also is to use the tool for the tasks that you have to do anyway, and just see which tasks it can do well and which it cannot do well. And also be very, very skeptical. Every time you get some output, be very skeptical and try to look for mistakes and hallucinations, and then you can iterate and find tasks that it's more useful for you. Let me close with a quote that summarizes all of this, which is by Simon Willison. Use a large language model like an intern who can read a lot, never gets tired, never gets upset if you change the task, but is way too confident about his abilities. Okay? Thank you very much. Have a great day.